There's something between the chest and the stomach that moves before you've decided anything. Not pain, not quite discomfort. Something more like pressure arriving without an invitation. A tightening that you notice only after it's already happened, already settled, already doing whatever it came to do. You probably know it. You felt it before you could name what was wrong, before the thought finished, before the word arrived. Welcome to the Sleepy Biologist. And before anything else, thank you to those who've been here a while, who've left a kind word in the comments or kept this space alive through membership. You are the reason this quiet exists. If tonight is your first time, something in your body already brought you here, and that's worth noticing. What we're doing tonight, slowly, is following guilt, not as a feeling, but as a physical event, as a thing that happens in tissue, in chemistry, in inherited wiring. It begins here in this chapter because it begins here in the body, before language, before intention, before you've had time to decide whether what you feel is even warranted. The anterior cingulate cortex, a strip of neural tissue folded into the medial wall of your brain, is one of the first structures to register what researchers sometimes call a prediction error. Not your mistake exactly, more like a mismatch. Your nervous system holds a kind of ongoing expectation about how social situations should unfold. What was said, who was hurt, what should have been different. And when reality doesn't match that expectation, something in the anterior cingulate fires, quietly, quickly, well before your prefrontal cortex has assembled a coherent thought about what happened. It runs faster than language does. That's the part that tends to surprise people, or at least it surprises me, every time I return to it. The sensation arrives first. The guilt arrives first. And the story you tell yourself about why you feel guilty comes afterward, constructed backward, fitted to a physical event that was already underway. You didn't decide to feel it. Your nervous system detected a gap, and something in that gap had weight. The fan on an old laptop is humming somewhere in this image of a quiet night. You know the sound, the low drone of something working without being asked. That's almost exactly how this process feels from the inside. Running, not announced. The anterior cingulate doesn't operate in isolation. It maintains constant communication with the amygdala, a structure more commonly associated with fear, though calling it a fear center misses most of what it actually does. The amygdala evaluates social relevance. It assigns emotional weight to incoming information, and in the case of guilt-adjacent signals, it tends to amplify. The result is that the mismatch detected by the anterior cingulate doesn't stay small. It gets handed off, processed again, given more texture than it started with, and all of this happens in a window of time so narrow it can be measured in milliseconds. You are not consulted. There's something worth sitting with in that. Because guilt, the specific guilt that comes from things you couldn't control, things that weren't yours to change, this kind of guilt begins the exact same way as guilt from something you actually caused. The brain doesn't check causality first, it checks outcome. It checks the gap between what its model predicted and what the world produced, and if that gap is large enough, the signal goes out. The tightening happens, and only later, sometimes much later, does the prefrontal cortex arrive to ask whether this reaction was even warranted. Often it isn't, but by then, the cortisol has already started. Cortisol is released in response to social threat, not only physical danger, but the perceived danger of a damaged bond, a failed expectation, an outcome that carries relational weight. In small amounts, over short periods, this is regulatory. The body prepares, the body tries to respond. But when the source of the signal is something you couldn't have changed, When the outcome was never yours to control, the preparation has nowhere to go. The cortisol circulates. The anterior cingulate keeps checking. The amygdala keeps waiting. It's not a flaw exactly. It's a system doing what it was designed to do in a situation it wasn't designed for. There's something almost tender in that if you let yourself look at it. Your nervous system is not punishing you. It's running a protocol that evolved for a world in which most social ruptures could be repaired with action. Move toward the person, offer something, try again, and the body still believes in that world, even when the situation doesn't allow for it, even when the thing that went wrong was structural or historical, or simply outside of what one person could affect. The tightening, then, is not evidence of guilt in any moral sense. It's evidence that you're wired for repair. You feel it because you are connected to something. That's worth keeping close tonight, not as a comfort exactly, more as a fact. The sensation has a source, the source is not a verdict, and somewhere deeper in the body, further down, there are longer timescales at work. Older circuitry, inherited tendencies. We'll get there slowly. Before there was language for it, there was still the feeling. Some primate, a social one, living in a group it depended on for warmth and food and protection, would do something that disrupted the group's equilibrium. A small aggression, a misjudged interaction, a moment of taking too much, and afterward, something would happen in that animal's body that looked, from the outside, a great deal like what we'd call guilt. Head lowered, proximity sought. Grooming offered unprompted to the animal it had displaced. The behaviour was not symbolic. There was no internal monologue. But the neurochemistry driving it was real, and it is the same neurochemistry running through you right now, in the quiet, long after the situation has passed. That's the part I keep returning to, not the behaviour itself, but how far back it goes. The affiliative bond, the biological tie between individuals in a social group, is not simply emotional. It has a molecular substrate. Oxytocin, which most people encounter in the context of birth or attachment or warmth, is also the molecule that makes the bond feel worth protecting. It's what makes the relationship matter in a cellular sense. And when something threatens that bond, when an action disrupts the felt coherence of the connection, oxytocin dynamics shift. The molecule that was sustaining closeness becomes, briefly, part of a different signal. A signal that something has to be done. This is where it becomes interesting and a little strange. The same neurochemical system that creates attachment is partially responsible for the distress of rupture, not as punishment, more like a consequence built into the architecture. You can't make something matter without also making its disruption legible to the body. And so guilt, in its oldest biological form, the form that predates human language by millions of years, is the body registering that something it was chemically invested in has been destabilized. In macaques, researchers have documented post-conflict behavior with enough consistency that there are now terms for its distinct phases. Reconciliation, consolation. The animal that caused the disruption approaches first, usually, presents itself, waits. The waiting is not passive, heart rate is elevated, cortisol is measurable, the body is in a state that won't fully resolve until contact is re-established, or enough time passes that the nervous system downgrades the threat. They don't know they're guilty, but their bodies are running the same basic error correction protocol that yours runs tonight. What changed across the long arc of primate evolution was not the protocol. What changed was the complexity of the situations it got applied to. Human social life introduced something that no other primate has to manage quite the same way: moral abstraction. the capacity to feel responsible for outcomes you didn't directly cause, the capacity to hold yourself accountable to a standard you constructed or inherited or absorbed from a culture that existed before you did. The anterior cingulate cortex, which expanded significantly across hominin evolution, gave the human nervous system the ability to run social simulations, to model what should have happened, compare it to what did, and register a gap even in the complete absence of a physical disruption. You can feel guilty for something no one witnessed, for something no relationship was visibly damaged by, for something that happened only in your imagination of what you might have done differently. The ancient protocol doesn't know the difference. This is worth pausing on, though pausing doesn't resolve it. The cortisol that rises when you replay a situation, the low-level glucocorticoid hum that settles into the hours of an unresolved evening, is chemically indistinguishable from the cortisol that arose in a macaque after a real, physical social rupture. The body is not running a sophisticated moral calculation. It's running a very old damage assessment program, and that program was never built to distinguish between things you caused and things that simply happened in your social vicinity with an outcome you didn't want. It just detects the gap, and it responds. There's something I find quietly difficult about that. Not distressing exactly, more like tender and a little unfair, that the nervous system of a highly empathic, highly socially aware human is in some ways more vulnerable to this particular loop than a less connected one would be. The tighter the bond, the larger the oxytocin investment, the sharper the signal when anything near that bond goes wrong. People who feel guilt most acutely are often people whose affiliative wiring runs deep. That's not a pathology. It's the cost of caring at a neurochemical level. But it does mean that the guilt you feel for things you couldn't control is not, biologically speaking, a mistake in the system. It's the system working exactly as it was built to work, in a world that no longer matches the one it was built for. The primate that lowered its head after a conflict could approach, could groom, could wait for the tension to resolve through physical contact and proximity. The repair pathway was available, but you, lying here, feeling the residue of something that was never yours to fix, or that happened too long ago, or that involved people who are no longer reachable, your nervous system is still offering that same repair protocol, still generating the distress signal, still waiting for an action that would resolve it, and no action comes because there isn't one. The vagus nerve, which we'll return to later in a different way, carries some of this bidirectionally, from body to brain and brain to body, regulating the intensity of the signal, negotiating between what the nervous system is generating and what the situation actually warrants. In well-regulated states, it can soften the loop, let the cortisol clear, allow the anterior cingulate to quiet. But this takes time, and it takes a certain kind of physical settling that is very difficult to force and slightly easier to allow, which is perhaps what this is. Not a solution, not an explanation that dissolves anything, just the slow acknowledgement that what moves in you tonight moved in animals long before guilt had a name. That the weight is old, that the wiring was never designed for the specific situation you're in, and that somewhere in the body, deeper than the cortisol and the error detection and the affiliative chemistry, there are other processes running. Quieter ones, longer ones. Systems that were calibrating and adjusting and responding to social experience across generations, not just within a single life. We're not done with inheritance yet. There's a fold of tissue buried inside each hemisphere of your brain that you will never feel directly. You can't locate it by pressing anywhere. It doesn't announce itself. But right now, in this particular kind of quiet, it is almost certainly doing something. The insula. It receives signals from the body's interior, from the gut, the chest, the skin, the muscles, and it translates them into something your conscious mind can use. Not words, exactly, more like states. Warmth, unease, the specific hollowness of embarrassment, the particular tightness that arrives before you've named what's wrong. You know that tightness. It lives for most people somewhere between the throat and the stomach. A mild constriction that isn't pain but carries the texture of it. The insula is, in part, where that sensation is assembled, where signals from the body's interior get shaped into something recognizable. And here is where it becomes strange, and I find myself not entirely sure how to hold it. The insula processes physical pain and social pain through circuits that overlap. Not adjacent circuits, not similar ones. Overlapping. The same region that responds when you stub a toe, the anterior portion of the insula, shows activation when you experience social rejection, when someone you care about is hurt, when a relationship you value is suddenly uncertain. The tissue doesn't run a separate program for each, it runs variations of the same one. This has been confirmed across neuroimaging studies with enough consistency that it's no longer particularly contested. Social pain is not metaphorically like physical pain. At the level of neural processing, the distinction is thinner than language makes it seem. What this means for guilt specifically, the insula cannot check your intentions. There is no mechanism in its circuitry for retrieving whether you meant to cause something. It receives the signal, there is pain nearby, there is social disruption, there is an outcome that carries relational weight, and it responds. The guilt sensation that you feel for something that wasn't your fault is not a confusion. It's not your moral system misfiring. It is the insula doing its job with the information it has, which does not include a timestamp, does not include a causal audit, does not include any record of what you wanted or tried or couldn't have known. It just knows something happened, and something happened near you. The precision of that is almost difficult to sit with. Not disturbing, just genuinely odd in a way that deserves a moment. The tissue that registers your own physical injury is the same tissue registering the injury of someone you're connected to. Empathy has a substrate. It is not a disposition or a personality trait floating free of biology. It is insular cortex activation, measurable, replicable, present in people who have no language yet for what they're experiencing. Infants show it. Animals with sufficiently developed insular cortex show versions of it. You came with it already installed. And so the guilt you feel for someone else's pain, the guilt that arrives even when the causal chain clearly runs nowhere near your choices, passes through the same neural tissue as your own hurt. Your body holds it in the same place, processes it through the same circuitry. There is no dedicated chamber for unearned guilt that your system might eventually learn to route things through. Instead, all comes through here, through this fold, through tissue that is doing exactly what it was shaped to do, which is to keep you deeply, sometimes uncomfortably, tethered to the people around you. That tethering has a cost. Tonight, it feels like this. It doesn't announce itself. That's the first thing worth knowing about what happens when guilt settles in for longer than a day. There's no spike, no sudden flood of chemistry that you could point to and say, there, that's when it began. What happens instead is quieter and in some ways harder to track. The hypothalamic pituitary adrenal axis, which coordinates the body's stress response, stays mildly, persistently active. Not at crisis levels, not at the level your body would reach if something genuinely threatening were standing in front of you, just on. A low hum of preparation that never quite receives the signal to stop. The hypothalamus, a small region at the base of the brain, sends a chemical message to the pituitary gland. The pituitary sends its own message down to the adrenal glands, which sit on top of the kidneys, and the adrenal glands release cortisol. In acute stress, this cascade is fast and useful. It sharpens attention, mobilizes glucose, temporarily suppresses processes the body considers non-urgent. Digestion, certain immune functions, the slow work of cellular repair. The body becomes briefly a machine aimed at a single problem. But when the problem is a feeling, when the problem is a gap between what happened and what you believe should have happened, and that gap has no physical edge, no boundary you can reach, the cascade doesn't stop, it just keeps producing. After a few hours of sustained low-level cortisol, the first changes are already underway. Inflammatory cytokines, small signaling proteins that the immune system uses to communicate, begin to shift. Cortisol in short doses is actually anti-inflammatory. It's one of the reasons synthetic versions are used medically. But cortisol sustained across hours starts to produce a paradox. Immune cells, repeatedly exposed to glucocorticoid signals, begin to develop what researchers describe as glucocorticoid resistance. They stop responding to the anti-inflammatory instruction, and what follows is a slow, diffuse increase in baseline inflammation. Not the sharp inflammation of an infection, nothing you'd necessarily feel as pain, but a systemic low-grade state that touches nearly everything. This is the part I find most difficult to sit with comfortably. Because inflammation at this level, and subclinical, quiet, spread across tissue rather than concentrated, is implicated in an uncomfortable number of downstream effects. Mood regulation, cognitive clarity, the quality of sleep. I tend to think people underestimate how connected these things are, how one chemical state seeps into the next without a clear border between them. By the end of the first day of unresolved guilt, sleep architecture is already affected. Cortisol and the sleep cycle have a relationship that runs in both directions, and it is not a cooperative one under these conditions. Normally, cortisol follows a diurnal rhythm, low at night, rising sharply in the early morning, helping to pull the body out of sleep and into wakefulness. When the HPA axis is running at sustained low activation, that rhythm flattens. The nighttime floor rises. Cortisol levels during sleep are higher than they should be, and the result is a measurable reduction in slow-wave sleep, the deep restorative phase where the body does some of its most important maintenance work. Less cellular repair, less immune consolidation, less of the growth hormone release that happens predominantly during slow-wave stages. You sleep, but something is different about it. You might notice this as waking earlier than you wanted to, or as sleep that doesn't seem to have landed quite right by morning. The hours were there, the time passed, but something feels like it didn't complete. This is not imagination. The architecture was disrupted. The chemistry was still running its guilt-adjacent protocol through the hours that were supposed to be quiet. Across several days, something else shifts. The hippocampus, a structure involved in memory consolidation and critically in the regulation of the HPA axis itself, is sensitive to sustained cortisol in a way that becomes relevant here. The hippocampus normally acts as a brake on the stress response. It sends inhibitory signals back up through the circuit, helping the system recognize when the threat has passed, when cortisol can come down. But prolonged glucocorticoid exposure interferes with hippocampal function. The brake weakens. The HPA axis loses some of its sensitivity to the signal that says, "Enough, we can stop now." The system that was supposed to regulate the stress response becomes gradually less able to do so. This is not a catastrophe. The body has redundancy. Other regulatory mechanisms are still operating. But it helps explain something that people who carry guilt across weeks sometimes notice, a growing difficulty in letting things go. A sense that the mental and physiological state of unresolved tension has become somehow the default. Not because they've decided to keep feeling guilty, Because the biology of prolonged cortisol has quietly adjusted the threshold, it becomes easier to detect threat, harder to dismiss it. What the body is doing in all of this is not malicious. It is doing exactly what it was designed to do in a world where sustained social threat usually meant a real, ongoing danger that required sustained preparation. The HPA axis, the cortisol, the inflammatory shift, the sleep disruption, each of these was adaptive once, in an environment where unresolved social rupture had consequences that cortisol could plausibly help address. It's just that the guilt you feel for something you couldn't control gives the system nothing to work with. The preparation runs, the chemistry accumulates, the threshold lowers, and no resolution comes, because the situation was never resolvable by cortisol in the first place. There is a particular kind of biological patience in that. The body waiting, adjusting, preparing for an action that was never available. Somewhere in your chest, the hum is still going, quieter now maybe. The night has its own chemistry, its own slow opposition to the day's residue. The cortisol rhythm, even when flattened, still has a floor it returns toward. Something in the body is always at some level trying to get back to baseline. It hasn't finished trying. Most people meet oxytocin in its gentler form, the warmth after close contact, the specific calm that follows being held by someone you trust, the way a familiar voice can shift something in the chest before a single word has registered consciously. Oxytocin's present in all of that, moving through the bloodstream, binding to receptors in the brain and the heart and the gut, softening the nervous system's vigilance just enough that closeness becomes something the body leans into rather than guards against. That part is true, but it isn't the whole picture. The same molecule that makes attachment feel safe also makes the nervous system more sensitive to anything that threatens it. This isn't a side effect, it's structural. Oxytocin receptor density in regions like the amygdala and the anterior cingulate cortex means that the molecule which opens you toward connection also sharpens the signal when that connection is disrupted. You cannot increase the warmth without also, in some neurochemical sense, increasing what the absence of warmth costs. Think of it this way, briefly. A door that opens more easily also lets more in when it swings the other direction. But don't hold that image too long. The biology is more specific than any image allows. In practice, what this means is measurable. Research on oxytocin and social pain shows that individuals with higher oxytocin reactivity, whose systems release more of the molecule in response to positive social contact, also show stronger neural responses to social rejection. The anterior cingulate fires harder. The insula activates more completely. The felt disruption of a damaged bond is not just emotionally larger, it is physiologically larger. More signal, more tissue involved, more cortisol in the aftermath. The intensity of guilt, then, is not a character flaw. It is in part a measurement of how much oxytocin was involved, of how much the bond mattered at a molecular level, of how deeply the nervous system had invested its chemistry in the connection. When guilt arrives with unusual force, when it seems disproportionate to the situation, when it persists beyond what seems reasonable, this is sometimes the oxytocin system doing its accounting, registering the size of what it built, feeling in proportion the size of what it perceives as damaged. You probably already knew this in some form, not the neurochemistry of it, but the fact of it, that the guilt you feel most sharply tends to involve the people you love most, that strangers don't produce this particular weight, that the intensity of the feeling has always seemed, in some quiet way, like information about the relationship rather than evidence of wrongdoing. That intuition was correct. It was always correct. What the biology adds is just the substrate, the molecular reason why caring and vulnerability are not separate experiences, but the same experience, arrived at from different directions. Oxytocin built the closeness. Oxytocin sharpened the detection of its disruption, and the guilt that sits in you now for something that may not have been yours to prevent. It moves through the same tissue, the same receptors, the same chemical channels that your warmth toward that person has always moved through. Same molecule, different moment. That's worth holding very gently before you sleep. When there's nothing to do with it, the brain doesn't stop. That's the first thing. The absence of an action doesn't produce quiet. It produces a particular kind of searching. The nervous system, which spent millions of years evolving inside bodies that had real physical problems requiring real physical solutions, doesn't have a clean protocol for threats that live entirely inside the gap between what happened and what should have. So it does the next available thing. It runs simulations. The default mode network is a set of brain regions, the medial prefrontal cortex, the posterior cingulate, the angular gyrus, the hippocampus among them, that become most active not during focused tasks but during rest, during the absence of external demand. It was named originally for what it does by default when nothing else is required of it, and what it does consistently is turn toward the self, toward social relationships, toward past events and their possible meanings, toward futures that haven't happened and the ways they might unfold. It is extraordinarily good at this. Under ordinary circumstances, this network is responsible for some of the more valuable things a mind can do. Planning, self-reflection, understanding other people's perspectives, constructing a coherent narrative of who you are across time. These are not small things. The default mode network is not a flaw in the system. It is, in a very real sense, the seat of much of what makes human cognition distinctive. But when guilt is the unresolved variable, when the situation has no physical boundary, when there is no one to approach, no repair that's available, no action that closes the gap, the default mode network does what it always does. It models, it replays, it adjusts one variable in the simulation and runs it again. What if I had said something earlier? What if I had understood sooner? What if the outcome could have been different if only... And then the simulation runs, produces an outcome, and the gap between that outcome and reality registers in the anterior cingulate, which is still watching, which is always watching, and the signal goes out again. A loop. Not a metaphor for a loop. An actual loop in the neurological sense, a circuit of activation that feeds back into itself, where each pass-through reinforces the pathway slightly, makes the next pass marginally more available, lowers the threshold for the circuit to fire again. Something outside the window shifts. A car passing, the particular silence that follows it, and then the mind is back inside. This is where the insular cortex returns. Each simulation that involves social pain or perceived failure reactivates the anterior insula to some degree. Not at the intensity of the original event usually, but measurably. Enough to refresh the felt sense. Enough that the guilt doesn't fade the way a memory with no emotional charge would fade. Because the insula keeps it embodied, keeps it present tense, keeps it tethered to a physical sensation rather than letting it drift into the past where it might gradually lose its grip. The simulation feels real because the body responds to it as though it is. This is the mechanism, not a moral failing, not a habit that willpower can simply interrupt. A circuit that has, by a particular set of neurological conditions, become self-sustaining. Each activation of the default mode network produces a simulation. Each simulation touches the insula. Each insular response confirms to the amygdala that this situation still carries threat-relevant weight. The amygdala signals the anterior cingulate. The anterior cingulate registers the gap again, and the default mode network, receiving that signal, turns its attention back to the problem. Knowing this doesn't stop it. I want to be honest about that. Understanding the loop, naming its components, tracing the circuit from network to cortex to amygdala and back, none of this interrupts the activation. The biology doesn't pause because it's been identified. If anything, the first time you really understand how the loop works, the understanding itself can become material for the loop, folded in, examined, replayed. What changes over time is different, and it's slower than an explanation. There's a process called extinction learning, the gradual weakening of a conditioned response through repeated non-reinforcement. In ruminative loops, what this means roughly is that each time the simulation runs without producing a new, confirming emotional response, the circuit loses a small fraction of its strength. The loop doesn't stop, it attenuates. Slowly, across days and weeks, the trace becomes slightly shallower. The threshold for activation rises, almost imperceptibly. The gap between replays lengthens. This requires, among other things, sleep. Slow-wave sleep is involved in memory consolidation, but also in emotional memory processing, specifically in the separation of emotional charge from episodic content. There is evidence that during REM sleep, the emotional coloring of a memory is partially stripped away while the factual content is preserved. The event remains accessible. The felt urgency attached to it diminishes. The hippocampus, which plays a central role in this, works through the night on exactly this kind of processing. Provided the sleep architecture is intact, provided cortisol hasn't raised the floor too high, provided the loop loosens enough to allow descent. So the loop, in a strange way, is partly what sleep is for, not exclusively. But the overnight attenuation of emotionally charged memory traces is a real process, running in the background, doing something useful with material the waking brain couldn't fully resolve. The rumination that felt inevitable at 11 o'clock is sometimes, by morning, slightly thinner. Not gone. Thinner. The trace a little shallower than it was. The body has been working on it. Right now, in this particular kind of near quiet, the default mode network is still active. It almost always is when attention isn't claimed by something external. It may be turning toward the event again, running another pass, adjusting a variable, but the thalamus is beginning its own process, starting to gate the flow of sensory information inward, starting to lower the bandwidth available for simulation. The loop doesn't stop because willpower stops it. It stops because the brain, given enough physical quiet, runs out of the metabolic resources to sustain it at full intensity. It gets slower and slower, and the body, which has been carrying the weight of a problem it was never equipped to solve, begins, very gradually without announcement, to put it down for the night. There is a region in the lateral prefrontal cortex, precise, slow, expensive in terms of the metabolic resources it requires, that does something most people never think about consciously, because it runs beneath conscious thought. It evaluates authorship. When an outcome occurs in your social world, something in this region works to determine where the causal chain actually began, whether the action originated from you or was shaped by pressure, or was accidental, or was structural, or was simply the inevitable product of a situation that had already been determined before you arrived in it. When it functions well, this system is genuinely precise. It can distinguish between a choice and a reflex, between an intention and an outcome that diverged from it, between something you caused and something that happened to occur in your proximity with consequences you absorbed. the ventromedial and ventrolateral prefrontal cortex, working in coordination with the temporoparietal junction, which handles the attribution of mental states and agency to self and others, can, under the right conditions, draw these distinctions with considerable accuracy. Under the right conditions, cortisol changes the conditions. Sustained glucocorticoid presence, the kind that accumulates across days of unresolved guilt, the kind discussed 2 chapters ago, reduces prefrontal metabolic activity. This is documented, replicable, not subtle at higher levels. The prefrontal cortex is among the brain regions most sensitive to glucocorticoid exposure, partly because of the density of cortisol receptors in its tissue. And when those receptors are saturated across extended time, the precision of prefrontal function decreases, not uniformly, not completely, but measurably. The calibration slips. Think of it, briefly just once, like the fine adjustment on a compass that has been left near a magnet for too long. It still points somewhere, but the reading is off, and the error compounds with distance. What this means in practice for the specific question of where responsibility ends, under high cortisol, the prefrontal system that evaluates agency becomes less discriminating. It assigns authorship more broadly. The threshold for self-attribution of negative outcomes lowers. Events that arrested cortisol-regulated prefrontal cortex would correctly classify as outside your causal influence get pulled inward, get claimed, get filed incorrectly under things you were responsible for. This is not a moral failure. It is a physiological one. And even failure is too strong a word for what is simply a system operating under conditions that degrade its precision. Sleep deprivation compounds this further. After even one night of significantly reduced slow-wave sleep, prefrontal metabolic activity drops in ways measurable by neuroimaging. The regions involved in impulse regulation, in nuanced social judgment, in the careful parsing of causal chains, they operate at reduced capacity. The person who slept poorly and is already carrying elevated cortisol is running an agency evaluation system that is, by measurable degrees, less accurate than it would otherwise be, less capable of correctly identifying where their influence ended and where the situation's own momentum took over. And guilt, under these conditions, expands to fill the available space. There is something else, though, that sits underneath the cortisol and the sleep deprivation, something longer. There are relational histories, patterns of early caregiving, the specific emotional environment of childhood, the implicit lessons absorbed about who is responsible when something goes wrong, that leave traces in the very architecture of prefrontal development. This is where the biology becomes harder to hold without care. The prefrontal cortex is among the slowest developing structures in the human brain, not reaching full maturation until the mid-20s. During that long developmental window, the calibration of the agency evaluation system is being shaped by experience. Environments in which children are consistently held responsible for outcomes they didn't cause, in which emotional disruption in a caregiver was implicitly attributed to the child's behavior, in which the attribution of blame ran broadly and without precision. These environments don't just create psychological patterns, they shape the neural circuits that will later do the work of deciding what belongs to you. The methylation patterns on stress response genes, the density of glucocorticoid receptors, the baseline tone of prefrontal amygdala connectivity. All of these are influenced by early relational experience in ways that persist into adulthood, that affect how sensitively the system fires, how quickly cortisol rises in response to perceived social threat, how readily the prefrontal system loses its precision under pressure. Some people arrive at adulthood with an agency evaluation system that was trained by years of accumulated experience to pull in too much, to claim what isn't theirs, not because they chose to, because the calibration was set that way, gradually, across years of a nervous system developing inside a particular environment and doing what nervous systems do, learning the rules of the world it was growing in. This is not destiny. The prefrontal cortex retains plasticity well into adulthood. Calibration can shift. The system can learn over time and under the right conditions to be more precise, but that shift is slow, and it is not something that happens through understanding alone. The tissue has to be given new experience to learn from, new evidence, a different pattern, repeated enough times to begin rewriting the old one. Tonight, the calibration is what it is. The guilt you're carrying, some portion of it, possibly a large portion, may be sitting in prefrontal tissue that is assigning you authorship of something the evidence doesn't actually support. A system running at reduced precision, claiming outcomes that were never yours to claim, doing so not out of accuracy but out of a long-trained habit of reaching too far. The body doesn't know yet that it's reached too far, but somewhere in the slow chemistry of the night, the cortisol is beginning to clear. And with it, very slightly the calibration may be shifting back towards something more accurate, more just, more willing to return what never belonged to you in the first place. Small things do disproportionate work. Corticotropin-releasing hormone is a peptide, 41 amino acids, produced primarily in the paraventricular nucleus of the hypothalamus, released in pulses carried through portal blood to the anterior pituitary, where it triggers the next step in the stress cascade. You've already met its downstream effects. Cortisol was the chapter before this, but CRH acts on its own as well, separately from cortisol through its own receptors in the brain. And at night, specifically during the hours the body has set aside for a particular kind of sleep, CRH does something that cortisol alone doesn't fully explain. It suppresses REM, not dramatically, not like a switch, more like a hand pressed lightly against a door that was trying to open. REM sleep, rapid eye movement sleep, the phase most associated with dreaming, with emotional memory processing, with the overnight attenuation of charged neural traces, requires a specific neurochemical environment to initiate and sustain. Low norepinephrine, low serotonin, relative GABAergic inhibition of the brainstem regions that would otherwise keep the body in lighter stages. CRH disrupts this environment. It increases norepinephrine release. It raises arousal thresholds in directions that push against REM initiation. The door stays mostly closed. What this prevents is worth naming plainly. The hippocampal amygdala processing that happens during REM, the slow separation of emotional charge from episodic memory content, doesn't complete. The ruminative traces from the evening don't attenuate the way they would across a full architecture of REM cycles. The prefrontal cortex, which requires REM for certain aspects of its overnight recalibration, gets less of what it needs. Morning arrives with the residue intact. This is the part I find quietly uncomfortable, honestly. That the very stress produced by unresolved guilt actively prevents the sleep stage most capable of processing it. The biology closes the door on its own solution. Not out of cruelty, there's no intention in any of this, but as a simple mechanical consequence of a stress system that doesn't know the night is supposed to be different from the day. CRH doesn't know it's nighttime. It rises when the signal says rise. It suppresses what it suppresses. The 41 amino acids do their work without consulting the hour. And somewhere in the body right now, the door is either open or it isn't. You feel other people before you understand them. This is not a poetic observation. It is a description of sequencing, the order in which the nervous system processes another person's distress. Something in the body responds first, a slight shift in chest tension. A change in breathing rate so subtle you wouldn't notice it if you were looking for it. A mild activation somewhere in the gut. And then, afterward, the conscious recognition. Something is wrong with this person. I am affected by it. The sequence matters because it means empathy, whatever else it is, begins as a bodily event. Mirror neuron systems, distributed across the premotor cortex, the inferior frontal gyrus, the superior temporal sulcus, were first described in macaques in the 1990s in a finding that was almost accidental. Neurons that fired when the animal performed an action also fired, at reduced intensity, when the animal observed the same action performed by another. The motor system was, in some sense, running a shadow version of what it was watching, not imagining it abstractly, simulating it in the body's own tissue, as though to understand from the inside what the outside was doing. In humans, the system is more distributed, more complex, and its exact role remains a subject of genuine debate among researchers. What is better established, documented across neuroimaging studies with reasonable consistency, is the co-activation of the anterior insula during the perception of another person's pain or distress. The same region that registers your own internal states, your own social pain, your own physical discomfort. It activates partially when you witness those states in someone you're connected to. Partial. That qualifier is doing real work here. The activation is not identical to what happens when you experience the distress yourself. It's attenuated, filtered, not a complete copy, but it is not nothing. It is not purely cognitive, not simply an intellectual understanding that someone is suffering. There is tissue involved. There is insular cortex firing. There is, in a measurable sense, something happening in your body in response to what is happening in theirs. The hum of a refrigerator in a quiet kitchen 3 rooms away. The kind you only hear when everything else stops. This is the substrate of empathy. And it has a cost. Not always, not in short exposures, with sufficient recovery, in relationships where the emotional exchange has some reciprocity. But in sustained contact with another person's distress, particularly distress that can't be resolved, that keeps presenting itself, that the empathic nervous system keeps receiving and processing and absorbing, the insular activation accumulates. The stress response is partially engaged repeatedly by experiences that are not even your own. Cortisol rises, inflammatory markers shift. The body treats what it is receiving at the level of tissue as something that requires response. This is sometimes called empathic distress. It's distinct from compassion, which neuroimaging research suggests has a different, less costly profile, associated more with approach motivation and less with shared suffering. Empathic distress is the experience of being pulled inside another person's pain to the degree that it becomes, biologically, something like your own. Highly attuned nervous systems, those with greater insular sensitivity, higher oxytocin reactivity, a developmental history that trained deep attunement to others' emotional states, run this process more intensely. The internal echo is louder, the tissue response is stronger, the body absorbs more, and here is where guilt without causation finds its home. When the empathic nervous system has been running a shadow version of someone else's distress, when the insula has been partially activated, when cortisol has been quietly responding to pain that originated elsewhere, the body is already in a state that resembles the state it would be in if you had caused something. The chemistry is similar. The felt sense is adjacent. And the mind, which is always looking for explanatory narratives to attach to felt states, sometimes produces the nearest available one. I am feeling this. I feel this because something went wrong. Something went wrong because... And then the prefrontal cortex. If it is tired, if cortisol has been running, if the agency evaluation system has lost some of its precision, reaches for the nearest causal story, which is often because I didn't do enough, because I could have done more, because somehow this pain that I absorbed from someone I loved became evidence that I failed them. It wasn't. It isn't. What it actually was, what it actually is tissue doing its job too well. A nervous system built for deep social attunement running its empathy circuitry at full sensitivity, absorbing what it was designed to absorb, and then a mind trying to make meaning of a bodily state that already felt like guilt, without stopping to ask whether the guilt had a real causal anchor. The feeling came first. The story came second. This is not a comfort exactly. Knowing the mechanism doesn't retroactively unfeel the feeling. The insular cortex that has been absorbing someone else's distress doesn't release it cleanly just because the biology is named. But there is something in the naming that shifts the weight slightly, not removes it, shifts it. Moves it from the category of evidence about who you are to the category of evidence about how your nervous system is built. You felt what they felt, genuinely, physically in tissue. And then you held yourself responsible for not preventing what you were already carrying. That particular loop, feeling, absorbing, internalizing, blaming, runs in bodies that are wired for closeness. It is, in the most literal biological sense, the cost of caring about someone enough that your insula fires for them. It doesn't mean you failed. It means you were present, in the deepest physiological sense of the word, for someone you loved. The longest nerve in the autonomic nervous system doesn't stay in one place. It starts in the brain stem, in the dorsal motor nucleus and the nucleus ambiguus, and travels downward through the neck, branching as it goes, sending fibers to the larynx and pharynx, to the heart, to the lungs, to the stomach and the intestines, reaching as far as the colon before it's done, the vagus nerve, named for wandering. And it carries information in both directions, not only instructions from brain to body, but signals from body to brain. A bidirectional conversation running continuously, below the threshold of awareness, shaping the felt texture of every social moment you've ever been in. Most people encounter it in the context of calming. Deep breaths slow the heart through vagal pathways. The sensation of genuine safety, physical presence with someone trusted, a voice that carries warmth, eye contact that doesn't carry threat, activates what Stephen Porges identified as the ventral vagal complex, a set of myelinated fibers that emerged late in mammalian evolution specifically for social engagement. When this system is online, the face softens. The middle ear attunes more precisely to the frequency range of human voice. Heart rate variability increases, which is a marker of flexible responsive regulation rather than rigid reactivity. The body under ventral vagal activation is ready to reconnect. This is the biological state that social repair requires. Not resolution exactly, not the intellectual conclusion that something has been worked through, but a physiological readiness to move toward, to soften, to let the face do what the face does when a relationship is being reapproached rather than defended against. The ventral vagal system makes that movement available. It lowers the body's defensive posture. It creates, at the level of tissue, the conditions in which repair can happen. But repair requires two things: the physiological readiness and the person. When the person is gone, when the situation is closed, when the relationship has ended, or the opportunity has passed, or the one who was hurt is no longer reachable, the nervous system has a problem that it wasn't designed to solve gracefully. The ventral vagal system still activates or tries to. The body still moves toward its repair-ready state. The face still softens somewhere that no one can see. The middle ear still shifts its tuning toward a voice frequency that isn't in the room. It's like a hand extended toward a door that has already closed. Not dramatic, just reaching and finding nothing to reach toward. The physiological sequence that was supposed to complete activation, approach, contact, regulation stalls at the third step. And a stalled sequence is not the same as a resting state. The nervous system isn't simply at baseline waiting. It's partway through a biological process that has no remaining path forward. The dorsal vagal system, which governs the older, less socially differentiated stress responses, withdrawal, shutdown, the particular heaviness that settles into the body when something can't be resolved, sometimes moves in to fill the gap. This is what incomplete repair can feel like from the inside. Not acute distress, something flatter. A heaviness with no clean edge, a tiredness that doesn't trace back to exertion. The body carrying the metabolic residue of a social process it began but couldn't finish. Right now, breathing is happening without your management of it. The diaphragm contracting and releasing, the vagus nerve carrying the signal of each respiratory cycle back to the brainstem, each exhalation producing a slight deceleration of the heart, a rhythm that has been running since before you were born, that was running before you had language for any of this. The vagal tone in this moment is being shaped by the breath, and the breath is being shaped partly by whatever the nervous system is still holding from the day. The repair cycle that couldn't complete is still open, somewhere in the body, still activated at low intensity, still waiting in the biological sense of waiting. A circuit primed for a next step that isn't coming. I don't have a resolution for that. I'm not sure there is one in any clean biological sense. What I do know is that vagal tone responds to time, to physical safety, to the specific kind of stillness that isn't tense. The body lying still in a dark room, no threat in the environment, breath moving at its own pace. This is information the vagus nerve receives and transmits. Not enough to close the repair cycle, but enough maybe to let the nervous system know that the emergency posture isn't required right now. Enough to let the heaviness sit without the body bracing against it. The heart is slowing marginally with each exhale. It has been doing that this whole time. There is a question worth sitting with before the biology begins, not a rhetorical one, a genuine one, the kind that doesn't have a clean answer yet that researchers are still working through with considerable disagreement about the details. The question is this: how much of what you feel tonight was already in your body before you felt anything? Before the specific situation that brought you here? Before the relationship, the event, the outcome that left the guilt sitting in your chest? Before any of it? How much of the nervous system's tendency to reach towards self-blame, to lower its threshold for perceived wrongdoing, to sustain a stress response past the point where the evidence warrants it? How much of that was deposited in you before you had the chance to deposit it yourself? The answer, as best as current epigenetic research can offer, is more than most people expect. Epigenetics, the study of heritable changes in gene expression that don't involve alterations to the underlying DNA sequence, has been producing findings over the past 2 decades that are still, in some circles, being absorbed with a degree of resistance. The resistance is understandable. The implication is uncomfortable. Not philosophically uncomfortable exactly, but structurally so. It asks the nervous system and the self to be understood as something more porous, more continuous with the bodies that preceded them, than the usual model of individual experience allows. What the research has documented, across multiple human cohorts and with increasing replication, is this: the experience of severe, unresolved stress in one generation leaves chemical marks on specific genes in the next. Methylation, the addition of small chemical groups to DNA, can sense or amplify gene expression without changing the underlying genetic code. And the genes most consistently implicated in stress response inheritance are those that regulate glucocorticoid receptors, particularly in the hippocampus where, as discussed earlier, the brake on the HPA axis lives. Think of it briefly as a volume dial that was set by someone else's hands before yours ever reached it. A dial controlling how loudly the stress response speaks, how readily cortisol rises, how sensitive the threat detection circuitry is to signals that might otherwise pass beneath the threshold of alarm. Set higher than baseline, not broken, the mechanism itself is intact, just tuned by the chemical residue of another person's unresolved distress toward heightened sensitivity. Then set down, passed forward, into tissue. The research on Holocaust survivor descendants, on children of famine survivors, on offspring of individuals with PTSD, these cohorts consistently show altered glucocorticoid receptor gene methylation, altered cortisol profiles, elevated baseline HPA axis reactivity, compared to control populations whose parents did not carry the same history of sustained unresolved threat. The alterations are measurable in saliva, in blood, in the stress response curves that these individuals produce in laboratory conditions before any personally significant stressor has occurred. The body arrived already knowing. Never taught. The darkness in a room at this hour has a particular texture, not black exactly, more like the absence of the day's small insistences, the objects still present but refusing to assert themselves. What this means for guilt specifically requires some care in the handling. If the glucocorticoid receptor sensitivity is higher than typical, if the HPA axis fires more readily, sustains activation longer, takes longer to return to baseline, then the cortisol response to a perceived social transgression, even a minor one, even one that wasn't causally connected to anything you did, will be stronger, will last longer, will do more of the downstream work described in earlier chapters, more insular activation, more prefrontal suppression, more expansion of the agency evaluation system's reach. The guilt, in other words, will be felt with greater intensity, will persist with greater stubbornness, will more readily attach itself to things that shouldn't carry it, not because of anything you did, because of a methylation pattern, because someone in the generation before you or before them lived through something the nervous system couldn't fully metabolize, and the chemical residue of that incomplete processing was written into the expression of genes that regulate how much stress costs. I find myself uncertain how to hold this in a way that feels both accurate and fair, because on one side there is the genuine scientific documentation of a real mechanism, not metaphor, not folk wisdom about trauma running in families, but measurable epigenetic alteration with identifiable molecular pathways. And on the other side there is the risk of a kind of biological fatalism, which the research doesn't actually support, but which the human mind, especially one already inclined towards self-blame, might easily construct from the available material. So it seems worth being plain about what the inheritance does not mean. It does not mean the sensitivity is permanent. Epigenetic marks are not fixed in the way genetic mutations are. Methylation patterns change. Experience continues to write on the genome across a lifetime. Therapeutic relationships, sustained physical safety, practices that consistently engage the ventral vagal system, even certain forms of exercise and sleep. These leave their own marks, gradually altering the expression of the same genes that were tuned by the previous generation's distress. The dial can move, it moves slowly, and it requires real conditions to move, not simply understanding. But it is not static. It also does not mean that the guilt you feel is not yours. This is a subtler point. The inherited sensitivity didn't manufacture the feeling, it amplified it, broadened it, lowered the threshold for it. But the care that underlies the guilt, the relational investment, the genuine concern for someone else's well-being, that is yours. The oxytocin, the insular activation, the prefrontal cortex trying to do accurate moral accounting, those are yours. The inheritance shaped the volume. It didn't write the content. What it did, in the most concrete biological terms, is make the body a place where guilt lands harder and stays longer than the situation usually warrants. And some portion of the weight you're carrying tonight, not all of it. The proportions are impossible to calculate and probably differ for every person. Some portion was placed in you before you were born, by a nervous system that was doing its best to prepare you for a world it believed, based on its own experience, was more threatening than it turned out to be. That preparation costs something. It costs you something still. There is a particular kind of grief in that, if you let yourself feel it, not the dramatic kind, nothing that requires action, something quieter. The recognition that some of what you've held as evidence of personal failure is, at the molecular level, inherited architecture, weight that was packed into the body before the body had any say in the matter. You didn't choose it. You didn't cause it. You've just been carrying it, the way tissue carries everything, without knowing it was there, without knowing it was separate from you, without any reason to question whether the heaviness was yours to begin with. It wasn't entirely, it never entirely was. Something is not happening right now. The anterior cingulate cortex, which has been present throughout this entire night, running its quiet audit, measuring the gap between what happened and what should have, registering the mismatch, signalling forward, is losing voltage. Not gone, not off, just quieter. The metabolic demand of sustained error detection requires glucose, requires oxygen, requires the continued attention of neural circuits that have been working since the day began. And somewhere in the descent towards sleep, those circuits start to release their hold. Not because the problem is solved, because the body, running low on the resources that vigilance requires, begins withdrawing them from non-essential monitoring. The gap stops being measured. For a moment, and it is genuinely just a moment at first, there is no comparison running, no model of what should have happened held up against what did. The anterior cingulate, which has been generating its soft alarm across hours, goes briefly quiet. The alarm doesn't resolve. It simply pauses. The tissue stops firing at the rate that produces the feeling of something unfinished. This is not resolution, worth being clear about that. The gap is still there. The situation hasn't changed. Whatever sits unresolved in the hours before this one remains technically unresolved. But the biological act of measuring it, the neural work of holding the standard and comparing it against reality over and over, each comparison refreshing the cortisol trace, that act requires a brain with sufficient resources to keep running it. Right now, the resources are going elsewhere. The thalamus is beginning its gating work. Sensory signals are being filtered before they reach cortical processing. The default mode network is losing its sustained activation. The hippocampus is beginning its overnight transition from encoding to consolidation. The anterior cingulate, somewhere in all of that, rests. What the body does in that pause is almost imperceptible. Heart rate drops slightly, breathing slows. The jaw, if it has been holding tension, and it probably has, releases a fraction. Not because anything instructed it to, because the signal that was keeping it marginally contracted has briefly stopped arriving. You may not notice any of this. That's the nature of it. The quieting doesn't announce itself. It doesn't feel like relief exactly. It feels more like the absence of something that was so constant you stopped registering it as separate from the background. The measuring stops, and the body, for just a moment, is not comparing itself to anything. Nothing needs to be finished tonight. That's not comfort exactly, it's just biology. The body moving into sleep doesn't wait for resolution. It doesn't check whether the prefrontal cortex has reached a verdict, whether the anterior cingulate has finished its accounting, whether the gap between what happened and what should have happened has been satisfactorily closed. It simply begins when the conditions are sufficient, the process it was always going to begin, and the guilt, the cortisol residue, the ruminative traces still circling in the default mode network, these don't get resolved, they get deprioritized. Quietly, without ceremony, the nervous system moves its resources somewhere else. Adenosine has been accumulating since you woke this morning. Every hour of wakefulness, every firing neuron produces this small molecule as a metabolic byproduct, a chemical record of how long the brain has been working. It binds to receptors throughout the forebrain, in the basal forebrain especially, and the longer it accumulates, the stronger the drive towards sleep becomes. Not a decision, a chemical pressure building across the day, now pressing against the waking state with the full weight of however many hours have passed since you last slept. The guilt doesn't cancel that pressure, it interferes with it as described earlier. CRH and cortisol both work against clean sleep architecture, and that interference is real. But the adenosine keeps accumulating regardless. The sleep drive doesn't care about the emotional state of the prefrontal cortex. It runs on its own timeline, its own chemistry, its own patient arithmetic. By now, the pressure is substantial. The thalamus, a paired structure deep in the center of the brain through which almost all sensory information passes on its way to the cortex, is beginning to change its behavior. During waking, it relays. Signal comes in, signal goes through, cortex processes, but as sleep onset approaches, thalamic neurons begin generating a different pattern. Spindle oscillations, bursts of synchronized activity at around 12 to 15 Hz, start to appear in the electroencephalogram. These spindles are one of the brain's mechanisms for gating sensory input, for reducing the cortex's exposure to incoming signals that would otherwise sustain wakefulness. The world gets quieter not because the world is quieter, because the thalamus starts filtering it. This is one of those biological facts that, when I sit with it, feels stranger than it initially appears. The idea that the boundary between you and the sensory world is not fixed, that the brain actively adjusts how much of the outside it lets in, that sleep is partly constructed by the nervous system's decision at a subcortical level to start closing certain doors. The thalamus doesn't ask permission, it just begins. The eyelids are heavy in a way that has a specific biological cause. The muscles that hold them open, the levator palpebrae superioris, innervated by the oculomotor nerve, require sustained neural drive to maintain their tone. As arousal decreases, that drive softens. The muscles don't fail, they simply receive less insistence from above. The eyelids descend of their own weight, gently, the way anything does when the force holding it up gradually withdraws. If this channel has been part of your nights, if you've found something here worth returning to, worth keeping alive through a membership or a kind word left somewhere, that matters more than it's easy to say cleanly. This space exists because people chose to stay. And tonight you're here again, which is its own quiet thing. The prefrontal cortex is losing its sustained coherence. The lateral prefrontal regions that maintain working memory, that hold the threads of complex thought, that keep the self-narrative running, They require constant metabolic support to sustain their activity. In the descent towards sleep, that support starts to withdraw. Thoughts become less sequential. The logical connective tissue between one idea and the next starts to dissolve. What remains are impressions, fragments, images that don't quite connect to anything. The hypnic jerk, if it comes, is a brainstem event, a sudden muscle contraction, the nervous system briefly misreading the relaxation of muscle tone as falling, producing a corrective startle that arrives before the cortex can contextualize it. It means nothing, and is just the old machinery briefly confused by the transition. The default mode network, still running somewhere, but losing its sustained activation, the simulation slowing, the gap between what happened and what should have. Still there, technically, still registered somewhere in the anterior cingulate's residual activity, but the circuit running it is losing voltage, not resolved, just running slower. The breath is doing something different now. Slower, sheltered. The diaphragm moving with less effort, the body needing less oxygen because the metabolic demand is dropping, the muscles releasing their daytime tension in small increments that you wouldn't notice if you were looking for them. The guilt is still in the tissue. The cortisol hasn't fully cleared. The repair cycle the vagus nerve wanted to complete is still open somewhere, still waiting. Still. The thalamus is still gating. Adenosine still pressing, eyelids, the weight of them. Something is getting quieter that was